Right, here we are. We've got a Pi linesman's telephone 1705. That's not the date, by the way. It's the model number. As you can see here, we've got just like normal phone dialing arrangements here. There's a switch here. There's one side of the switch switches that there's like a voltage in here that goes in. There's about 1.5 volts in here, and go in the side of it. If I can show you that there, you can see the battery connectors there. So you take that thing out, put your batteries in and screw it back on. Then you switch this one onto here, this circuit SCB, and that switches the battery into circuit. So that's across here. If you were to measure it, there would be about 4.5 volts roundabout coming out of these terminals here. There's two wires go from here, and it's a wired system, so it can go up to hundreds of meters away, you know, sort of thing. And you can have another one, an identical one like this at the other side, and you can use it as a phone, because the actual if you can see here, this is the handset. There's a switch. There's a send and receive switch. So when you press start, you're talking, and when you let go, you're listening. A bit like a CB type switch. But this works off a carbon. Well, this is a carbon microphone which generates its own little voltage, which is then superimposed onto 4.5 volts. This battery here, which then has some sort of transformer arrangement to send that voltage across a long distance, so it doesn't get lost. And it's picked up at the other end. Then there is no amplifiers inside these or anything like that. It's simply straightforward carbon microphone like the old phones used to be. No amplification circuit whatsoever. And very clever how they actually work. So that's the thing there. So what I'm doing is I've got another one here, which that's what's inside the there. I don't know if you can see that one there. That's what's inside it. And just to give you a quick demonstration of what everything is in here, you can see this thing here is the buzzer, and it buzzes. I'll show you it working in a minute. We've got this is that's the switch that you can see, that this switch here. So that's that switch there. You can just about sort of see it. See, these are all GPO switches. Very complicated arrangements. But it shorts a load of wires out at the same time, basically, by clicking it back and forth. Here we've got a transformer here. This transforms the actual voltage, so it can actually step up voltage to make this thing work, because these things on a normal exchange would work about 90 volts AC. So when you call somebody on a normal phone, you'll probably, over these two connectors here, you'll measure 48 volts, nearly 50 volts basically. It's 48 volts across there. That 48 volts is used to transfer the signal from the microphone and superimposed it, if you like, so that it can go over a long distance. But there is no actual microphone circuit in there at all, or headphone circuitry. It's purely driven by transformers to step up things and to make things work. The only difference is here we've got a little ringing generator here, which is, you can see where my finger is there. This is the ringing generator, and using 4 transistors. Okay, so we've just looked at this, at the ringer circuit, and now we're going to look at the main circuit. As you can see here, we've got all the wires here that are coming in. That's where I've wired my LED, which has got a little resistor in, so it works off more than 3 volts that an LED normally works at. Check your LED first to make sure what the forward voltage is. I'm only going by this one, which was 3 volts. So what we got here, we've got this is a bit where the you can't see it underneath, but this is where the handset is wired in there, if you like. you could probably just about see it if there, you can see the wires going into there. So those are your wires into your handset. Quite sort of straightforward again, and you've got enough there. You've got your sort of microphone outputs, earphone output, and so on. Each one has got its own connections here, as you can see. And we've got on this board, bearing in mind that across the terminals, the power comes in, which is over here where I've got my crocodile clips from the other one. These are wired to these over here. Another little transformer here, except it's not like the big transformer, it does a different job. I believe, and I could be wrong, that this is a step-up transformer. So it steps up the small voltage at one side and comes out at the other side. I'd have to get these two terminals here. Those are two end ones because the other ones aren't used. As you can see there, 3 and 7. But I don't know, somebody else might be able to tell me. I haven't checked these or measured them out just yet, but I'm taking it's a step-up transformer. So small voltage goes in, big voltage comes out, enough to make this work. So it also works at the 90 volts AC, which is sent by the telephone exchange. So there must be something in there that must step that up to make it work. But when you disconnect it from the exchange and you're using the battery in here, obviously we still need that 90 volts to make that work. And I have measured that across there, and there's still 90 volts going into this, even though there's only 4.5 volts. So that I think is a step-up transformer. But correct me if I'm wrong. We've got other things in here as well, for smoothing out the audio and stuff, I suppose. But it's mainly to do with power and to make it work with a 48 volt supply. 4.5 volts is quite straightforward. There's not really much needed there. But when it gets to about 40, 50 volt, 45, 44, 48, 50 volts, obviously we need to bring that down to the same voltage as the operating voltage for the telephone, and that's kind of how this is basically working. Its main voltage is 4.5 volts. So I'm taking it here that this must bring that 48 volts to make it work with this system, and so you can see how it works. These don't work on the battery, so I take it these only work with the exchange voltage. Maybe one's I'm not too sure how these are laid out, but one's reversed round to the other. So I take it one must be an incomer and one must be an outgoing. So it indicates the ringing coming in and the ringer going out, or the exchange in and exchange out. But again, I need to find this out. So you can see how it works. It's quite fairly straightforward. There's nothing magical about it. Bear in mind, in transformers, nothing is actually physically connected to one to the other. So it's like a coil inside, so that you can step up voltage and you can step down voltage, but these are isolated between the input and the output. So you can put say 12 volts in and get 240 volts out if the windings were wound enough to do so, and likewise you put 240 volts in and you get 12 volts out, and that's basically how it works. But bear in mind, what comes out of here is not DC, it is AC.